All right, looks like the video paused at the end there. So here for number 17, here's the Lewis dot structure of the fluoroberylate ion. And notice beryllium here normally has just 2 valence electrons, but it has to make a single covalent bond with each fluorine atom. And so it has a formal charge of -2. Each fluorine atom has a 0 formal charge on it because it has exactly 7 electrons at its disposal. All right, so your answer here, because it's asking for the formal charge on the beryllium atom, it's -2. Number 18, a reaction where the products are higher in energy than the reactants is an example of, we know when energy is higher after the reaction, we know energy has gone into the system, more energy has gone in than has left, and so that's an endothermic process. Number 19, the oxidation number of sulfur in K2SO4, you have to figure that out. For oxygen, it's -2 times 4, which is -8. Everything has to add up to 0 because it's a neutral compound. Okay, potassium's +1 because it's group 1, so 2 times 1 is +2, so that means sulfur has to be +6 to add up to the 6 plus 2, which is 8, which has to add up to 8 in order to balance out the -8 from the oxygen. So the oxidation number on sulfur is +6. For number 20, give the molecular geometry of XeF4. So here we have to draw out the Lewis dot structure for the compound. Xenon is a noble gas and has 8 valence electrons. It takes 4 of those electrons and makes covalent bonds with fluorine. Okay, so fluorine has 7 valence electrons, so it has 3 lone pairs and 1 electron that it's sharing with xenon. All right, so the question is, what is its molecular geometry? So here we can see we have 6 electron pairs, 1, 2, 3, 4, 5, 6. So its electron pair geometry would be octahedral. But because it has 2 lone pairs here, okay, if you remember from the PhET simulation, it's going to be square planar. So this is going to be basically look kind of like an X on the same plane here, an X shape, and so that's square planar. Number 21, your answer, of course, can be any of these. Okay. Number 22, choose a formula for the compound iron 3 nitrate. So iron is +3 because that's what it's. The Roman numeral dictates the oxidation number on the iron. Nitrate is a polyatomic ion, NO3, with a -1 charge. So to balance out the charges here, if we have +3 from the iron, we need -3 for the nitrate. And so we need to put a parentheses 3 there. And so this is your answer there. Number 23, draw a Lewis dot structure for NO3-. How many total resonance structures must be drawn to completely describe the bonding? Okay, so when we draw one of these, now you don't have to draw all of these, it's a multiple choice question. You could look at it and tell that, well, you know, you're going to have one single bond. I can write it here in the middle, on the left-hand side, or on the right-hand side. But these are 3 resonance structures. Okay, so your answer there is just 3. So once you draw out this initial structure, you should be able to see that, oh, we can move that double bond around. So there's 3 possibilities there. Or you can draw it out and, you know, then write in your answer. All right, but this is not, you know, multiple choice doesn't have to be short answer. It's either all right or all wrong. Okay, so don't feel like you have to. I hate to say this, you probably should show your math when you're doing math problems and when you're writing out resonance structures, but I can't give you partial credit for a multiple choice question. All right, number 24, which of the elements listed below has the greatest electronegativity? Okay, so if we look at the elements given there, I'm going to have my periodic table up earlier. Okay, so we're comparing these different elements here, which has the greatest electronegativity. So here we have Our first answer choice is gallium here, Ga, iron, selenium, antimony, and potassium. So most of the elements are on the same row with the exception of antimony, which is one below. So we know electronegativity increases as we go up. Okay, so antimony is definitely not going to be the answer. As you go left to right, electronegativity also increases. Okay, so selenium is the element that is the furthest to the right side here. And so that's why it has the greatest electronegativity. It's furthest to the right. All right, number 25. Here we have a value 2.4 liters, and that's how many milliliters. So it's just a simple conversion here. So I take 2.4 liters. My conversion factor here for every 1 liter, that's 1,000 milliliters. So I'm basically multiplying 2.4 times 1,000, which is 2,400 milliliters. Number 26, which of the following elements is chemically similar to oxygen? So if we look at our answer choices here in the periodic table, so here we have oxygen, and then our first answer choice here, nickel, is over here. So obviously it's not in the same family. Sulfur is, okay. Calcium is not. It's way over on the other side here. Sodium is not. And then iron is in the middle here. So obviously sulfur is in the same family as oxygen, so it's chemically similar to oxygen because it's in the same family. All right, number 27. Which of the following has the larger radius, sodium or sodium plus? We know if sodium loses an electron, it loses the entire shell, right? Sodium only has one valence electron, okay, so, in its outer shell. So when it loses that one valence electron, it always is smaller. It's always smaller because it loses an entire shell when it loses that one electron. So sodium is larger than sodium plus. Remember, cations are always smaller than their neutral counterparts. And anions are the opposite. Anions are larger than their neutral counterpart. So remember that as well. All right, number 28. Which best describes the iron or the ion Fe3+, so iron plus 3. So iron plus 3, if you look it up on the periodic table, it has 26 protons. Right there, 26, atomic number 26. And so it's going to have 26 protons. It has a plus 3 charge, so it lost 3 electrons, right? So that means it doesn't have 26 electrons, it only has 23. Okay, and then the number of neutrons here, if you look on the periodic table, its average atomic mass roughly, it's almost 56. If you take 56 and subtract 26 from that, you get 30. Okay, so if you wanted to nitpick about neutrons, well, look here, iron's always going to have 26 protons. Okay, so your answer choices really should only be between B or C for that, because of that fact. And so then you have to make sure you remember to subtract 3 electrons from the number of total protons, because it lost 3 electrons. That's why it has a plus 3 charge there. All right, number 29. What is the molarity of a solution that contains 0.64 moles of sodium chloride and 250 mils of solution? All right, so we know molarity is moles of solute per liter of solution. So it gave us the moles, it gave us the volume in milliliters. We have to convert that to liters. So a quick way of doing that is you divide by 1,000 or move the decimal point over 3 places to the left. And so that's how I get the 0.250 liters. Divide to get 2.6 molar. And that's the concentration of your solution there. Number 30, the current atmospheric pressure in Dalton is 767 millimeters of mercury. What is the pressure in atmospheres? So you have to remember the conversion factor here is 760 millimeters of mercury is equal to 1 atmosphere. Okay, so when we set up our simple one-step conversion here, we get a total atmospheres of 1.01 ATM. Okay, so that's our answer there. Number 31, which of the following elements has the smallest ionization energy? So here I'm going to refer back to the periodic table so we can compare the different elements. All right, so I've lost my periodic table. All right, so here we're trying to find the element that has the smallest ionization energy. So we're looking at lithium, sodium, beryllium, potassium, and rubidium. Okay, so the smallest ionization energy. So we know that ionization energy goes up as you go up, increases as you go up the periodic table. The sizes of the atoms get smaller as you go up the periodic table. So the larger the atom, the lower the ionization energy. And so rubidium is actually the element that's the lowest on the periodic table here. Okay, it's the largest atom out of those listed there for answer choice, and so rubidium is going to have the smallest ionization energy, meaning it takes the least amount of energy to remove an electron from the neutral atom, and that's because it's larger than the others. All right, number 32, how many electrons are shared in a double covalent bond? So just a reminder here, there are 2 electrons that are shared in a single covalent bond, 4 in a double and 3 in a triple. So your answer should be 4 there for a double covalent bond. Number 33, an oxide ion, O-2, has what? It has 8 protons because it's oxygen, and it has, instead of having 8 electrons, it has 2 more because it has a -2 charge, so it has 10 electrons. Number 34, name the following molecule, NO2. So NO2 is nitrogen dioxide. Okay, you use the prefix rules here because this is a covalent or molecular compound where you're dealing with 2 elements and they're both nonmetals. So you have to use the rules that contain the prefixes for both of the elements. Okay, because nitrogen, there's only one there. You don't have to use a prefix, and that's only when it's the first element. If there's only one and it's the second element, you have to include the prefix mono. Okay. Number 35, bromine is a red liquid at 25 degrees Celsius. Its density is 3.12 grams per cubic centimeter. What is the volume of 28.1 grams of liquid bromine? So here I have my density formula. I'm going to rearrange it here. I'm going to cross multiply. Density times volume is equal to mass. And then divide both sides by density to get volume is equal to mass over density. So the mass is 28.1 grams. The density is 3.12 grams per cubic centimeter. You divide that, you get 9.01 cubic centimeters. So that's your answer for number 35. Number 36, identify the element being reduced in the following reaction. So here you're having to assign oxidation numbers for each element. Here aluminum is by itself, so it's 0. Oxygen also is by itself, so it's 0. It's an uncombined element. On the right side, it is combined. Aluminum is +3 in this case, and oxygen is -2. So here for aluminum went from going from an oxidation number from 0 to +3. Oxygen went from having an oxidation number of 0 to -2. So they're asking you which element is being reduced. Reduced means it's increased in terms of number of electrons. So here oxygen would be your answer there. Remember the acronym oil rig. Oxidation is loss, reduction is gain. We're talking about electrons here. So when we have reduction, reduction is gain of electrons. And so here we see 2 electrons gained for each oxygen atom. So oxygen is your answer there. Number 34, which of the following atoms has the greatest electron affinity? Electron affinity means it has a large positive value. All right, it's the tendency of an atom to attract electrons. All right. So electron affinity. So if you look at your answer choices here, we have sulfur. Okay, we have phosphorus. We have gallium. We have lithium. And we have bromine. So we know the trend is here that electron affinity increases from bottom up and from left to right. So if you're thinking, what is a preference here? From left to right is a preference first, and then from bottom up. So here bromine is to the right of any of your other possibilities, sulfur, phosphorus, etc. Bromine has 7 valence electrons, so it is going to have a higher electron affinity than something like sulfur, which only has 6. Okay, so your answer here is bromine. Number 38, given the electronegativity values of 0.9 for barium and 3.5 for oxygen, determine the bond type expected for barium oxide. So I know this is going to be an ionic bond because there are such large differences in electronegativity. Okay. Also, you're not going to have covalent bonding here is only going to occur when you have 2 nonmetals, and here barium is a metal. Okay. We haven't talked about hydrogen bonds yet at all. That will be next semester, so ionic bonding should be your answer there. Number 39, what type of electron orbital is designated by n equal to 3, L is equal to 2, m sub L equal to -1. So, so when we talk about orbital, I'm looking at my L value here. Okay, so I know it's going to have a 3 in front of it because it's energy level 3, right? And then L equal to 2. Well, if I go back here and derive that, an L of 0, these are my L values. An L of 0 is going to be an S subshell, an L of 1 is going to be a P, and L of 2 is going to be a D. Okay, so that means if it has an L of 2, it's in a D subshell. Okay, and its energy level is 3, so it's a 3D orbital. So A is your answer there. All right, number 40. So here is another quantum number question. What is the maximum number of electrons in an atom that can have the following quantum numbers? An N of equal to 4, so it's energy level 4. L equal of 1, so an L of 1 is a P subshell. N sub S equal to positive 1/2. All right, so here P subshell has 6 electrons, right? It has 3 orbitals, okay? If they're all have an ms value of +1, that's a spin up, so there's only 3 possible electrons that could have an n value of 4, an L of 1, and an m sub s value of positive 1/2. Now, if they would have given you the m sub L value there, okay, it'd only be 1, but they didn't do that. So there are 3 different electrons that could have these 3 different numbers, values. So 3 is your answer there. All right, here for part 2, we're going to start a different video for that one.